questions 1 through 10 of the 2000 grade 10 AMC 10. In the year 2001, the United States will host the International Mathematical Olympiad. Let I, M, and O be distinct positive integers such that the product I times M times O is 2001. What is the largest possible value of the sum I plus M plus O? So 2001 is equal to I times M times O, like that. Now, basically what that means is that we've got to factor out 2001. And there's many ways of doing that, but let's look at what is our biggest numbers, right? Because we want the largest possible sum of I plus M plus O. So 2001 is divisible by 3. And if you do divide it by 3, it becomes 3 times 6, 6, 7, like that. And this is a pretty big number. And then we can also put a 1 in there because we need 3. And this should be sufficient. I plus M plus O therefore becomes 1 plus 3 plus 6, 6, 7, and that is 671. Now, I think a common mistake is students were factoring out 2001 as 29 times 23 times 3, which is correct, but unfortunately when you then add up I, M plus O, it becomes 29 plus 33, 23 plus 3, and this is equal to 55. So they're circling B, which is the wrong answer. So take a little bit of time and understand that the largest sum, of course, is 671, and that would be choice E. 2000 times 2000 to the 2000. So 2000 multiplied by 2000 to the power of 2000, like that. Well, 2000 is really 2000 to the power of 1, and therefore if you're multiplying the bases and the bases are the same, you add the exponents like that. And therefore this becomes 2000 to 2001, and therefore that would be choice A. Each day, Jenny ate 20% of the jelly beans that were in her jar at the beginning of the day. At the end of the second day, 32 remained. How many jelly beans were in the jar originally? So at the start, originally, we have X jelly beans. And at the end of day 1, 20% are gone. She ate 20%. So how many remain? Are 0.x. 0.8x, right? Because you have to get rid of 20%. And then at the end of day 2, how many remain? Not 0.6. Don't make that mistake. That's wrong. You have to multiply 0.8, 80% of what is here, like that. Okay, that would be the correct way of doing it. So this is how many are at the end of the second day. And they've told you that is 32. So now we just have to solve for this. So we've got 0.8 times 0.8, which is 0.64. X is equal to 32. So therefore x is equal to 32 over 0.64. And this means that x is equal to 50. So the answer is B. So just backtrack here. 50 is our answer. So that means that at the start you had 50. And then at the end of day 1 you had 40. And then of course at the end of day 2 you had 32. Chandra pays an online service provider a fixed monthly fee plus an hourly charge for connect time. Her December bill was $12.48, but in January her bill was $17.54 Because she used twice as much connect time as in December. What is the fixed monthly fee? So we'll let the fixed monthly fee be F, and we'll let the hourly charge be X. So this is the fixed fee, and this is the hourly fee, like that. And they're saying that the fixed fee plus a certain amount of hourly fee is equal to 12.48. And that was the month of December. And then in in January, her bill is $17.54 because she's using twice as much connect time. So that means her hourly charge was double. She used twice as much. So that's 2x therefore. F plus 2x, like that. All right? So now we've got two equations, and we therefore just have to solve for them. So I will solve for this by putting 2 minus 1. That should be able to do it. So what do we get here? The f's cancel. We get 2x minus x is 17.54 minus 12.48. So x is equal to 5.06. Yeah, 5.06. But the question is asking what is the fixed monthly fee. So don't choose choice B. Read the question carefully. They're asking for F. So to find F, we just have to plug x equal to 5.06 back into here, and we'll get the value for F. So F is equal to 12.48 minus x. So 12.48 minus 5.06, and that is equal to 7.42. So that's what they're asking for. So this would be choice D. Points M and N are the midpoints of sides PA and PB of triangle PAB. As P moves along a line that is parallel to AB, how many of the four quantities listed below change? Okay, so we got quantity A, B, C, and D. So let's discuss each one. The length of segment MN. Well, since M is the midpoint of AP and N is the midpoint of PB, MN equals half of AB. All right? And it will always be like that no matter where P is. Even if P is here, and then you draw the triangle like that, MN will still always be half of AB. So AB never changes, right? P moves along that line, but AB never changes. So since AB never changes and MN is equal to half of AB, MN does not change. All right, so that's the first one. The second one, the perimeter of PAB. Perimeter. The perimeter is, of course, AB plus PA plus PB. Now, AB doesn't change, but how about PA and PN, or PB rather? Well, if you were to extend this line and put P way out there, look what happens. PA becomes much, much longer, right? So the perimeter will change. All right? The area of PAB. Well, the area is like that, where the line I just drew is the height, and the area of a triangle is, of course, 1/2 base times height. Now notice the base is this, and that does not change, and the height is here, and that will not change either. No matter where you put P, the height will always be the same. So therefore, the area will not change. So area does not change. And finally, the area of the trapezoid ABNM. So ABNM, this trapezoid. Well, what is the area of a trapezoid? It would be, if you have a trapezoid, I'll draw it out like this. And this is, say, A, and this is B, and this is a height. The area is written as A plus B over 2 times the height. So in our diagram, the area would be MN plus AB over 2 times the height. Now MN does not change. This one right here, we wrote that up there. The base AB does not change, and the height does not change, no matter where P is. So therefore, none of these values in the area formula change. So therefore, this area does not change. So the only one of these A, B, C, D that changes is B. So therefore, how many of the 4 quantities listed below change? And that would be this one only. So that's one of the 4. And therefore, the answer for number 5 is B. The Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, and 21 start with 2 ones. And each term afterwards is the sum of its 2 predecessors. Which of the 10 digits is the last to appear in the units position of a number in the Fibonacci sequence? So let's write this out. 1, 1, 2, 3, 5, 8, 13, 21. Now you understand what's happening, right? These are the first 2 numbers. Now, how did I get 2? I added the first 2, 1 plus 1. How did I get 3? I add the immediately preceding 2 numbers, 1 plus 3. How did I get 5? It's 2 plus 3. 8 is 3 plus 5. 13 is 5 plus 8. And 21 is 18 plus 13. So using the same process, let's write out a few more. So we got 34 for the next one, then 55, and then what do we have here? 89, I believe, and then 144, 233, 377, 610, 987, and just a couple more, 1597 and 2584. I think this should be enough for us to explain this. So what they're saying is you want to look at the last digit, the units position. The units position of a number is the last digit. And which of the 10 digits of course are from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is the last to appear. All right, well, let's see what appears. Let's start with the very first one. What is the units digit of 1? Well, it's 1. Units digit of 1 here is 1. Units digit of 2 is 2. 3, 5, 8. Now, in 13, what is the units digit? It's 3. So I'll just circle all the units digits of these numbers. All right? Now, let's see which ones have been counted. So I'll write them out. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The 1, immediately we got that. Then we got the 2, then we got 3, we got 5, and 8. We have 3, but 3 we've already circled. 1 we've already circled. 4 is the next one that we got. 5 we've already circled. 9 is the one we got. So now we still haven't gotten 0, 6, and 7. Let's see if we get those. This is 4, we've already got that. This is 3, already have that. 7, there you go. We got a 7. So we're now down to 0 and 6. Well, the very next one is a 0 as the units digit. So the last to appear in the units position of a number in this Fibonacci sequence is 6. Eventually, perhaps we'll get a 6 somewhere, but we don't need to figure out what that number is. They just want you to figure out what is the last number, and the answer is 6. So the answer to number 6 is C. In the rectangle ABCD, AD is equal to 1. P is on AB, and DB and DP trisect ADC. So that means this angle has been cut in 3. So it's a 90 degrees, so it basically means that that's 30, 30, and 30, like that. What is the perimeter of BDP? So BDP, this triangle, what is the perimeter? Okay, let's draw this out a bit bigger. So let's start labeling. AD is equal to 1, and then these lines DP and DB, they trisected that angle, and that angle of course is 90 degrees because it's a rectangle. So that means this is 30 degrees, this is 30 degrees, and this is 30 degrees. This is 90, and therefore this is 60. This is 90, and therefore this is 60. So we have a whole bunch of 30, 60, 90 triangles. And if you have a 30, 60, 90 triangle like this, 30, 60, 90, the ratio of the sides are 1, 2, and root 3, like that. So that's very important, and that's how we're going to solve this question. So this is 1 because that AD was 1, and this is a rectangle. So now let's figure this out. Let's see what we can do. Let's just figure out all the sides. Let's try this one first. Well, 1 over DB is going to be the same. Look at this triangle over here. The ratio is 1 over 2, right? It's a 30, 60, 90 triangle. So therefore DB is equal to 2. So write that in there too. So we got one side of that triangle, BDP. Now let's look at this one. In that one, same thing, 1 over AP is equal to what? Look at this triangle again. Be careful. The angle is a little bit different. It's opposite 60. So it would be root 3 over AP, which is opposite 30, over 1, like that. So that means AP is equal to 1 over root 3. So this is 1 over root 3. And let's do this one next. 1 over DC, looking at this, same story, is going to be 1 over root 3. So therefore DC is root 3. And then this one is going to be then, therefore, root 3 minus 1 over root 3. Because this whole thing is root 3, and from here to here is 1 over root 3. All right? So now we can figure out the perimeter. The perimeter of this triangle, PB, BD, and then PD, is PD, which looks like, oh, we didn't figure this out. Well, we got to figure that out then. That shouldn't be too hard. Using our 30, 60, 90 triangle, let's figure out PD. PD over 1 is equal to 2 over root 3. All right, there you go. Now we got everything. We're going to label that in there, 2 over root 3. So here we go. We got 2 over root 3 plus root 3 minus 1 over root 3 plus 2. That is our perimeter. Let's see if we can simplify all of this. Multiply top and bottom by root 3 just to rationalize that denominator. Same thing here. So we'll get 2 root 3 over 3 plus root 3 minus root 3 over 3 plus 2. So we got a common denominator, 3 and 3. So we have 2 plus 3, which is 5 minus 1. So 4 root 3 over 3 plus 2. 4 root 3 over 3 plus 2. All right, let's see if that's one of the answer choices. 4 root 3 over 3 plus 2, 7 is B right here. At Olympic High School, 2/5 of the freshmen and 4/5 of the sophomore took the AMC 10. Given that the number of freshmen and sophomore contestants was the same, which of the following must be true? All right, they are not saying that the freshmen are equal to the sophomores. No, they are saying the freshmen and sophomore contestants. So 2/5 of the freshmen took this math contest. So 2/5 of the freshmen were the contestants and 4/5 of the sophomores. And they're saying these two are equal. All right, so we've got to solve for this. So that means 2f is equal to 4s and f is equal to 2s. So there's twice as many freshmen as there are sophomores. So for example, if there's 50 sophomores, f would be equal to 100. And which of these would be 5 times, twice as many, twice as many, 5 times? I believe it looks like D. Twice as many freshmen as sophomores. If x minus 2 absolute value equals p, where x is less than 2, then x minus p. For those of you who are not familiar with absolute value, when you have those bars, it's known as absolute value. And what that means is just the distance from that number to 0 on the number line. So if this is 0, and this is the number line, 1, 2, 3, -1, -2, -3, like that, and you have a number on the number line, the absolute value of that number is the distance to 0. So for positive numbers, it's just the number. But if it's a negative number like -3, then the distance from -3 to 0 is 3. So if you had the absolute value of 3, it would be 3 like that. So they're saying the absolute value of x minus 2 is equal to p. X is less than 2. What is x minus p? And they've given you some answer choices. So I think the way to understand it most clearly is to just choose some values. So I'm going to choose x equals anything you want, as long as it's less than positive 2. Right? Don't say -2. So I'm going to choose -5. You can choose whatever number you wish. So let's go with this. If x is minus 5, that means x minus 2 is going to be -5 minus 2 absolute value. This is -7 absolute value, and that is 7. And therefore, that is equal to p, according to that equation. And then the next part, x minus p, would therefore be -5 minus 7, which is -12. So we have to look at our answer choices and figure out which one of them equals -12. All right, let's go through these one by one. First one is -2. Well, that's obviously not right. Next one is 2. That's not right. How about 2 minus 2p? Well, 2 minus 2p would be 2 minus 2 times 7, which is 2 minus 14, which is -12. All right, great, that matches. But let's do the other ones and ensure that we don't have two answers. How about choice D right here, 2p minus 2? Well, p we got was 7, so that would be 7 minus 2. This is 14 minus 2, which is 12. All right, that does not match, so that's wrong. And finally, E, which is 2p minus 2, the absolute value. Well, p is 7 down here. So we've got 2 times 7 minus 2, the absolute value. 14 minus 2, 12. The absolute value of 12 is just 12. And that doesn't match that. So the only one that matches is C. And therefore, number 9 is 2 minus 2p. The sides of a triangle with positive area have lengths 4, 6, and x. The sides of a second triangle with positive area have lengths 4, 6, and y. What is the smallest positive number that is not a possible value of the absolute value of x minus y? So if you have a triangle, let's say like this, and the sides are equal to what they've given us, 4, 6, and x, there's some important things that you always need to understand. The first thing is that x can only be less than the sum of the other two sides, right? If it was greater, you cannot make a triangle, because 4 and 6 cannot stretch out to make a triangle if x is, say, 50. So I hope that makes sense. So that's the first thing. That's the first fundamental property, is that x has to be less than the sum of the other two sides. But it has to be greater than the other two sides subtracted, 6 minus 4, right? Because if you have 6, and let's say you drew the other side like that, if this is 6 and this is 4, x has to be greater than 6 minus 4, which is 2, which would be about this much. It has to be greater, because if it's not greater, you can't make a triangle. If you try to make x equal to 1, then it wouldn't reach the end of the other side. So that's another fundamental property of triangles. So this basically becomes 2 and 10, like that. And it looks like the second triangle is pretty much the same story. So therefore y is less than 10 and greater than 2. So that's our first set of equalities. And now they're asking for the absolute value of x minus y. All right. So what I did is I just look at extreme case scenarios. I said, I want to make this as small as possible, right? That's what the question says. So how do I make this the smallest possible? I make this the smallest by making this the smallest, x. And then by making this the biggest. And see what I get. And if it doesn't work, we'll try something else. So what's the smallest I can get for x? Looking at this right here. Is it 2? No, because it cannot be 2. If x is 2, this is not going to be a triangle. It has to be greater than 2. So we'll say x is 2.01, right? That is fair. That's possible. It's going to be a really, really extreme triangle, but that is possible as long as it's greater than 2. And what about y? What's the biggest y can be? Can it be 10? Well, no, because if you make y at 10, you cannot make a triangle. But y could be 9.99. That is allowed. So now what does x minus y become? It becomes 2.01 minus 9.99. And this is minus 7.98, absolute value, which becomes 7.98. So you can never get 8. The only way you could get 8 if x was 2 and y was 10. But that's not allowed because x cannot be 2. It has to be greater than 2. And y can never be 10. It has to be less than 10. So even when I chose extreme case as close as possible, I still didn't get 8. I got 7.98. So 8 is a value that is not possible to get based on the lengths of our two triangles. All right, so the answer to number 10 is D.